already discussed the general solution of one-dimensional heat equation for finite length by the method of separation of variable. Okay, we discussed it in previous video step by step wise, and we know that this is a long process to solve or to find the general solution. So we, when practically use this formula or this method, we have to remember that the working rule of this method. So here we discuss the working rule of this method or solution of this method by method of separation of variable. Okay, we first write in the step 1, the temperature function is given by u of x comma t. This is equal to summation n equal to 1 to infinity en into sine n pi x by a into e to the power minus n square pi square k by a square into t. Okay, we directly write the solution or general solution of this problem. Okay, where the coefficient en is given by en, we know that en this is equal to, this is the Fourier coefficient formula. Okay, we write this result also. This is en, this is equal to 2 by a integration 0 to a f of x into sine n pi x by a into dx for n belongs to capital N. Now we compare our given problem or given particular problem with this general problem of one-dimensional heat equation, and comparing the first equation with the given particular problem, we get the particular value of k from the first. Okay, and from the second or from the equation number 2, we get the particular value of a here, because here it is given that this is a. Okay, so from this we get k, and from the second relation we get a, and from the relation number 3 we get the value of fx. Okay, now these three quantities are known for us, so we put the value of k, a and fx in this relation and this relation. Okay, and when we put the value of k, a and fx, we make the complete integration of this. Okay, here we put the value of a, here we put the value of a, and we put the value of fx, also put the value of a, and we determine the complete value of en by integrating. Okay, and now we put the value of k and a here, a and a here, also a here, and putting the value of en in the general solution. Okay, and get the value of u or the value of temperature function u x comma t completely. Okay, and our problem is solved. So we follow the step 1, and in step 2 we compare this three quantity, that this is the step 2, and putting the value of k, a and fx in step 3, and in step 4 we get the complete or specific value of the temperature function u x comma t. Okay, this is the complete working rule of one-dimensional heat equation by separation of variable. Okay, thank you for watching.